Squirts and giggles. Okay, so the first one gives us our u to begin with. U equals x over 3. All right. Okay, so we go and working with this. We get u equals x over 3. Du is equal to 1/3 dx. Probably not going to have the 1/3, but I'm going to let that go. I don't really have a good one here. So what I want to do is take this u equals x over 3, solve for x. That means 3u is equal to x. Right? Okay. Du equals 1/3 dx. That means 3 du equals dx, because I have the dx. So dx will be replaced, x's are replaced, everything is in terms of u. The numerical portions can remain or not change, kind of depends. So I get 3 du. Okay, I've done my substitutions. Now I need to do a little work to simplify things out. It's the integral of 1 over 9u squared plus 9 times 3 du. Equals the integral of 1 over 3u squared plus 3 du. See what I did there? Just reduced everything by 3. Okay. Pull out the 1/3. Now comes the point where you realize, oh crap, he was serious when he said back when we were learning our rules of derivatives that having the rules of derivatives memorized would come in very handy even when we were done with our derivatives. Because if you have your rules for derivatives memorized, you go, oh, 1 over something squared plus 1 is tangent, the inverse tangent. It's the inverse tangent. So this is 1/3 inverse tangent of u plus c. And what is u equal to? X over 3. So I put my x over 3 back in. 1/3 inverse tangent. And I don't know if I have to have the absolute value or not. I don't remember if I do or not. I don't think I do. X over 3 plus c. Yes. I'm trying to remember. I know with the logarithms you have to have absolute values. I'm trying to remember if some of the trig ones you do, some of them you don't. I'm not sure if you do on this one. I don't think you do though. I know logarithms you have to have absolute values because you're not allowed to take logarithms of negative numbers or 0. Okay. Inverse tangents I'm not sure about off the top of my head. I don't think so, but you know, it's not my test. Questions on this one? Okay. So one of the things when you start seeing them worked out, okay, your first problem on this one, number 33 from your homework. The most difficult thing to decide on is what is your u. Some of the rules that I gave you. If you see a fraction in your denominator, let u equal your denominator. Well, if I let u equal x, the derivative of x is dx. That doesn't do anything for my natural log thing. But if I think about something else, and if I stop and I look at this, I go, wait a minute. This is the integral of the natural log of x to the 6th power times 1 over x dx. If you can see that, those two being the same thing, it makes your decision for what your u is very simple. Because when I have my u and I take the derivative, I get du something dx. If I pick a u properly, then the other x terms go away as part of my dx. So what's my u going to be for this one? Natural log of x. If u equals a natural log of x, du is 1 over x dx. So this becomes the integral of u to the 6th du. Very simple one. Once you figure out your u, it's pretty easy. So this is 1/7 u to the 7th plus c, which becomes 1/7 natural log of x to the 7th power plus c. And you may or may not have seen this in your book yet, but your book likes to do this. 1/7 ln I've seen this. Your textbook was the first, and I do believe the only place I've ever seen this with natural logs. But calculus textbooks are really where you use natural logs more than anywhere else. You do them some in pre-calc. You do a lot in pre-calc, but not nearly as what you do in here. That means the same thing. It's the same notation as using sine squared, cosine squared, that kind of idea. It's the same idea. I've seen that as the problem be ln squared x. Well, that's natural log of x squared. Okay, so you just have to kind of be careful with that. I would stick with this as your answer. I'm just saying it's the same thing, just in case you see it in another notation. It's the different notation for the same thing. Just like sine squared, cosine squared.
So what happens to 1x? It just turns into du?
No. 1 over x dx becomes, because I have, what is du? Du is 1 over dx dx. That's du. That's part of what du is equal to. Okay. Once again, the most difficult part of this is picking out what your u is. One of the things you're going to do is when you choose your u, the concepts are, one, do I get what's left over when I take the derivative of whatever my u is? And two, am I making it simpler? The whole idea behind a u substitution is to make things simpler. So you want to pick a complex item, generally speaking, in order to do this. So what should my u be on this one? ln of x. ln of x. You should be in the natural log. U equals u equals ln of x. Du equals 1 over x dx. 1 over x dx. That's my du. So this becomes 1 over u du. What is the antiderivative of 1 over u? Natural log of u. So ln of u plus c. So substituting back in, it's the natural log of x plus c, which is not the natural log squared, because it's not the natural log of x times the natural log of x. It's ln of x of ln of x. You can't do anything to that. You have to leave that. Yes. No, because yeah, maybe, yeah, probably should. It's tough, but yes, it should. And I don't know how often. Okay, shh. And I know a lot of these questions in absolute value. They're great questions. Don't get me wrong, but I understand most of where they're coming from is, if I don't put the absolute value around it, am I going to get it wrong on the test? Right? Okay. On the AP exam, generally speaking, it's not too much of an issue. I've never really seen it be an issue on the free response. On the multiple choice, if it needs to be there, they will have it there as part of their answer. On my test, I'm not going to really get hung up on it. Okay? I'm not going to get hung up on the absolute value part on your test coming up in a couple of weeks. Yes?
When we're done with the questions, we picked up, maybe ask you something.
Yeah. still got a couple more to go. Two more? Yeah, two more, because I'm going to do the last one twice. Because there are two possible ways of doing the last one. Questions on here? Don't forget your plus C. Okay. Okay. First of all, trig functions. Oh my lord, I hate them when they're like this. Okay, 1 over the cotangent. What is 1 over the cotangent? It's the tangent. So the first thing you want to do is you want to say, all right, no. Now this is the integral of the tangent of 3x dx. And then the other thing you're going to do, okay, do I have an antiderivative for the tangent? No. But can I rewrite the tangent? Yeah. It's the integral of sine of 3x over cosine of 3x dx. Whenever you see tangent or cotangent, oh my God, yes, rewrite them in terms of sine and cosine. Okay, at least in this situation here. Now, what should my u be? Cosine of 3x. Cosine of 3x, let it be your denominator. Du equals negative 3 sine 3x dx. Okay. Because chain rule, 1, the derivative of the cosine is negative sine. So it's negative sine 3x times the derivative of 3x, which is 3. I don't have negative 3 sine 3x, I have sine 3x. So negative 1/3 du is equal to sine, I'm having problems today, sine 3x dx. There's my substitution. Negative 1/3, 1 over cosine 3x. Oh, sorry, cosine of, 1 over u, my bad. 1 over u du. And the antiderivative of 1/3, 1 over u du is negative 1/3 natural log of u, absolute value, just to make everybody happy. Well, not everybody, just some people. And then put back into 3x to start cosine 3x. Okay. What? Sure. All right, I should give you everything. Shh. Gentlemen, any questions on this one? It's all about picking your u. Maybe you have to rearrange things first. Once you get your u, generally is. Now, like I said, there are going to be some of them on the homework that I'm going to give you that I would never give you on the test, neither would AP. Okay. You do need to understand the derivative of the inverse tangent of x and the antiderivative of 1 over x squared plus 1 for the AP test. You have to know that rule. You have to know the one for the inverse sine. You must have those rules committed to memory, both from being able to take the derivative and recognizing what the antiderivative is. You absolutely need to know them. I've seen too many multiple choice questions in particular that have those on there. And if it's a matter of having things memorized, that's just sitting down with flashcards, writing it over and over again, whatever works for you to commit them to memory. And points are not easy to come by. And missing a multiple choice question because you didn't memorize a fact or a rule would be terribly disappointing. Now, I do understand you're sitting down to a test, you're stressed out, you know, things will go away. When you're under stress, that's when your brain starts not working so great. I understand that. But the better you have them committed to memory ahead of time, the less stressful you're going to be when you sit down because you'll be more prepared. The more prepared you are, the less stressed you are. Okay, so I hammer this preparedness bit. I really try to hammer that. Try to reduce the stress going in. Okay? Because that's a big part of it. Reduce your stress going into the test. Go in, hey, I'm going to do the best I can. I know what I know. I'm prepared. I've done everything I can to prepare. I'm just going to give it my best. And relax when you go in to take the test. A little bit of stress is good. A lot of stress is bad. And so you have to learn how to take tests. And this is a test that students get. And you're going to be in there from 8 o'clock in the morning until about 1 o'clock in the afternoon. It's a long freaking test. I'm just telling you. Time-wise, it's about 3 hours timed test, not including break time in between. Okay? You got a 30-minute section, you got a 45-minute section, a 30-minute section, and then a 90-minute section. There's 3 hours and 15 minutes just timed right there. It's long. Okay, this is absolutely one of my favorite problems. I love this problem. Okay? Because there are two solutions. Depending upon what you pick for your U. You have choices for your U. Somebody want to give me one to start with? Tangent of x. I love it. Perfect. Great choice. U equals tangent of x. Du equals secant squared of x dx. That's a nice straight substitution. Tangent secant squared dx. So this is the integral of u du, which is 1/2 u squared plus c, which is 1/2 tan squared x plus c. BCK. That's one possible answer. There's another one. Okay, has everybody got this one? BCK, right? Tangent. Derivative of the tangent secant squared. Oh my God. Derivative of the tangent secant squared. I can see it. Okay. There is another choice.
The question also has to evaluate consider or negative by a 4.
Okay. So does this one count from negative? Is this one evaluated that? Did I leave the evaluation off? What does it say? What's lower bound?
The original is negative pi over 4.
Negative pi over 4 to 0. Okay, that means you have two choices. Means you do, well, it means you don't need the plus c. Okay, and you have two choices. You can do that. Go back, plug in the tangent, put in the original bounds, and do that, and evaluate it. No, you have to evaluate. You got to plug in 0. You got to plug in pi over negative pi over 4 and evaluate. Or you can go back to here and say, okay, when x is equal to 0, then u is equal to, what would that be? Tangent of 0 is sine over cosine 0. So you can change your bounds. And then negative pi over 4, when x is equal to that, u would be equal to, the tangent of negative pi over 4 would be negative 1? Yeah, negative 1. So you could do that, you could either put the originals back in and do this, or you could go, okay, I'm going to evaluate, change my bounds to negative 1 to 0, negative 1 to 0, and just evaluate it that way. Either way. You can change your bounds and evaluate it in terms of u, or you can put back the original and use the original bounds and evaluate. Either one will work for evaluation. Okay. Done with this? Okay. I have another choice. Does somebody see my other choice for my u? Not secant squared. What's the derivative of secant squared? Derivative of secant squared would be 2 secant x, tangent x. 2 secant squared x tangent. I don't have 2 secant squared tangent x. Just plain secant x. Because this can be rewritten as tangent x, secant x dx. Because what is secant squared? Secant. So if I let u equal secant x, du equals tangent x, secant x dx. So I get the integral of u du, which is 1/2 u squared. And then, because I have to do the evaluating, put it back in 1/2 secant squared x. And evaluate it from negative pi over 4 to 0. And you'll end up with the same numeric answer when you're done. You'll get the same answer when you're done. Yes. What's the derivative of the secant of x? Oh, why is it secant squared? Because what's the antiderivative of u? 1/2 u. Questions? And you don't need to do a u sub for this one. 1 over cabin d cabin. What is the integral of 1 over cabin d cabin? Natural log cabin plus c? That's good.
I love it.
Yeah. No, because only you guys get it, and we feel the teachers. Of course. Yeah. No, not even half the teachers. This is the math department. And a couple of the science teachers. Okay.